All right, today we're going to dive into something really big happening in the world of artificial intelligence. We're talking about a shift away from AI that just learns patterns to AI that can actually reason and tell us how it's thinking.
I mean, think about it for a second. It's one thing for an AI to suggest a new song for your playlist. The stakes are pretty low. But an AI recommending a medical treatment? That's a whole different ballgame, right? And this is a question the entire field is grappling with, which brings us to the core problem that a really cool new approach, neurosymbolic AI, is trying to solve.
You see, for decades, AI has kind of had this split personality. On one side, you've got what we can call the logicians. These are systems built on pure hard-coded logic. And on the other side, you've got the learners, the deep learning models that are amazing at finding patterns and just tons and tons of data. And for like the longest time, everyone thought you had to pick a side.
Okay, so to really wrap our heads around what's happening now, we've got to break down these two kind of opposing brains of AI that have really shaped the entire history of the field.
So first up, we've got symbolic AI. Yeah, they literally call it good old-fashioned AI or GoFi. This was the big thing from the 50s all the way through the 80s. It's built on pure logic. If this, then that. Its biggest strength is that you can follow its thinking step by step. It's a glass box. But here's the killer problem. It's incredibly brittle. Throw some messy real-world data at it and, well, it just falls apart.
And that, of course, brings us to today's world of subsymbolic AI. This is the deep learning that powers pretty much everything now. It uses these things called neural networks to learn patterns from mountains of data. It's unbelievably powerful, but, and this is a huge but, a lot of the time we have no earthly idea how it gets its answers. It's a total black box. So this table really just lays it all out, doesn't it? The logicians give us reasoning we can understand, but they're fragile. The learners give us this incredible power, but we can't see inside. And for years, AI folks had to make a choice. You could get reason, or you could get learning. You couldn't get both in the same package. And that right there leads us straight into the single biggest hurdle for modern AI, especially when the stakes are high. We're talking about the black box problem. I mean, check out this quote from a major research paper. It hits the nail on the head. For us to really trust AI with critical stuff, like in our hospitals or in self-driving cars, it absolutely has to explain itself. This isn't just a techie problem, It's a fundamental issue of safety and trust. Okay, want to see what's at stake here? Let's talk about developing a new drug. It costs, on average, $2.8 billion and takes 12 to 15 years. You just can't bet the farm on a black box that can make a billion-dollar mistake and then not even be able to tell you why. The stakes are just way too high. Okay, but this is where the story gets really interesting, because this is where something called neurosymbolic AI steps in, promising to give us, well, the best of both worlds. So neurosymbolic AI, people call it NESI for short, it's not about picking a side anymore. It's all about bridging that gap. It takes the awesome pattern-finding skills of neural networks and combines them with the solid, explainable rules of symbolic logic. The whole goal is to build one system that can both learn and reason. And if you look at the main goals here, they're a direct answer to all the problems we've been talking about. The whole point is to build AI we can finally understand and trust, systems that can think logically, figure out their own mistakes, and even get smarter with less data. Okay, so that's the big idea, right? But what does this actually look like in the real world? How does it work? Let's pop the hood and take a peek inside one of these NESI systems. All right, now this diagram might look a little complicated at first, but the core idea is pretty straightforward. Don't worry about every single box and arrow. The big takeaway is this. In all these models, you've got the neural network doing the dirty work up front, processing messy stuff like an image, and then it translates what it sees into clean, logical symbols that the reasoning part of the AI can actually understand and work with. Okay, to make this super clear, let's walk through a real-world example from medicine that's, honestly, it's pretty incredible, helping to diagnose eye disease. All right, let's trace the journey here. First, on the left, the AI takes in an image of a retina. A neural network, that's the learner, scans it and highlights potential problems. And this right here is the magic trick. All that visual info gets converted into a structured, symbolic table, something a person and a computer can both easily read. Finally, another part of the system uses that neat table to make a prediction, but then it does something that's a total game changer. It explains why it made that decision based on the evidence in the table. And that is the huge difference right there. The AI isn't just spitting out, I think this is diabetic retinopathy. It's saying, I think this is diabetic retinopathy because I found 33 microaneurysms and 13 hemorrhages, and here's exactly where they are. It actually shows its work.
So you can imagine this ability to reason and explain, it just blows the doors open for what AI can do. But of course, it's not without its challenges. And just look at this. The potential applications are all over the map. For really critical fields like healthcare or cybersecurity, it gives us trust. For things like robotics, it gives us a much deeper understanding of the world. It could even make things like generative AI and recommendation systems way more logical and grounded. But, we're not quite there yet. This stuff is hard. There are still some really big puzzles that researchers are trying to solve, like the best way to wire these two brains together, how to even measure success, and finding that perfect balance between raw power and being able to explain yourself.
But the end goal, and this quote really captures it, is just so important. The whole idea is to build AI systems that are more transparent, more trustworthy, and more robust, especially in fields like healthcare, where you absolutely positively cannot compromise on those things. And all of this leaves us with one last, really big question to chew on. Right now, all AI is what we call narrow. It's good at one specific thing. But by teaching machines to combine learning with logic, are we actually laying the first real bricks for true artificial general intelligence? That right there is the question that's going to define the next decade of AI.